Welcome back, dear students. So let's continue with the new exercise on chapter 20. So in this particular exercise, you will be learning about three different kinds of diagrams. Okay, so the first kind of diagram is called trapezium. Okay, so trapezium. What is trapezium? Let's see. Now, trapezium is a quadrilateral. Okay, quadrilateral means four-sided figure, okay, where you have any two opposite sides to be parallel. For example, in this particular diagram, you see that this side and this side, they are parallel. Now, how do you know that they are parallel? Using this particular arrow. Okay, so you're using the arrow, it means that the sides are opposite. See, in case of trapezium, only two sides has to be parallel. Okay, now if the length of the parallel sides, okay, so the first side is A and the other side is B, and the distance between them is H. Okay, so basically H is the distance between the parallel sides, then its area will be equals to half into A plus B, that is sum of the length of the parallel sides into the distance between them. Okay, so this gives you the area of a trapezium. Right, so next is a parallelogram. Now all of you must be familiar with the figure of a parallelogram. So in parallelogram, what happens is pair of opposite sides are always parallel and equal also. Okay, so that means this side and this side, they are parallel, and this side and this side, they are parallel. Okay, they are parallel, that's okay, but with that, what happens here is this one will be equals to this one, and this side will be equals to this side. Okay, now in such case, or in case of parallelogram, the area formula will be base into height. Okay, so base, if you take this to be base, then the distance between these two will be the height. Okay, so if you call this to be base, then the distance between these two, that is this H, represents the height. Okay, so this is all about your area of a parallelogram. Now there is one more special kind of figure called rhombus. Now what is rhombus? Rhombus is also a parallelogram where all the sides will be equal to each other. Okay, so rhombus is a parallelogram, but in case of rhombus, all the sides will be equal. And if that happens, okay, then its area, see, first and foremost, it is a parallelogram. So can we apply a formula for parallelogram for finding area? Yes, definitely, right? So if you have a side means you can take this to be base, and if you have the height, then base into height or side into height gives you the area. So this is the same formula as of the parallelogram. But in case of rhombus, we have got one more formula. Now, if you know the diagonals of the rhombus, suppose in this case, this diagonal is given to be A and this diagonal is given to be B, then the area becomes half into A into B, that is half into product of the diagonals. Okay, so in case of rhombus, we have got two formula for finding areas, whereas in case of trapezium and parallelogram, there are only one formula for finding the area. Okay, so you may pause the video and note down the diagram and area formula so that we begin with the sums on exercise 20C. So let's see the first question. So first question is on the screen, which says the following figure shows the cross section ABCD of a swimming pool which is a trapezium in shape. So see, this is the cross section of a swimming pool. Okay, so that means here this AD, okay, so AD and BC represents the depth. Okay, and all of you know, in a swimming pool, some or one corner will be of less height and other corner will be of greater height, isn't it? So this slope, you can see this AB, so this slope is the base of the swimming pool, remember, and the CD is what? The CD is the surface of the swimming pool. Okay, so if I ask you what shape is this, obviously you see the arrows out here. Okay, so here I see that these two sides are parallel. So whenever we have only two sides parallel, then it becomes the shape of a trapezium, right? Okay, now if the width DC is the distance between the parallel sides, so can I call DC to be the height? Yes, right? So width DC of the swimming pool is given to be 6.4 centimeter. So this is given to be 6.4 centimeter. Okay. Depth AD at the shallow end is given to be 80 centimeter. So this AD is given to be 80 centimeter, and the depth BC, that is this BC, is given to be 2.4 meter. Okay, so 2.4 meter, right? Now what you need to do is you need to find the area of cross section. You need to find the area of cross section. Okay, so remember the formula is half into, okay, so let me write down the formula. So it is half into A plus B into H. So this is the formula for finding area of the cross section, and you know cross section is in trapezium shape. Okay, so let's find what are A, B and H here. Okay, so from the figure we have A. Okay, A and B, you know, they represent the parallel sides, so you call this as A. Okay, it becomes 80 centimeter. Okay, call B to be this side. This is another parallel side, right? So this is 2.4 meter, and the distance between them, distance between the parallel sides, is my H, right? So H is nothing but, okay, so let me write this also. Let me write this also. So A represents your AD or DA, whatever you want to call it. So let me write this as AD. Okay, AD is given to be 80 centimeter. B is your BC. Okay, so BC represents your B, which is 2.4 centimeter, and the distance between them is DC, which is given to be 6.4 centimeter. Okay, now let's find the area of the cross section. Okay, so area, therefore area of the cross section will be, area of the cross section is equal to, okay, so let me see what is the area. Just wait a minute, let me check the question in book once again. Okay, it is given to 6.4 meter, I guess. Yes, this is meter. Okay, this is not centimeter, this is meter. 6.4 meter. Okay, not centimeter. Okay, so we have this is given in meter. Okay, AD is given to be 80 centimeter. Yes. Okay, and this is also given to be meter. I'm sorry, this is also given to be in meter. Okay, so if all these are in meter, let's convert this also in meter. So if you convert this into meter, this becomes 0.8 meter. Okay, now area of the cross section will be half into A plus B into H. Okay, so let's put the values. Half into A is given to 0.8 plus B is 2.4 into H is 6.4. Okay, so half into, so we have 0.8 plus 2.4, so it becomes 3.2 into 6.4. okay, so when you calculate this turns out to be 10.24. okay, so your answer is going to be 10.24 meter square. So this will be the area of this cross section, right? So you may pause the video and note down your solution. Okay, so next we have two parallel sides and distance between them are in the ratio 3:4:2. Okay, so understand the question. So this is question number 3, right? So the two parallel sides and the distance between them are in the ratio 3:4:2. Okay, so two parallel sides means A, right? A and B. So basically what is given is the ratio between two parallel sides and the distance between them, that is h, is given to be 3:4:2. Okay, and the area is given to be 175 centimeter. You need to find the height. Okay, so in this case, in case of ratio, what we do is we will take A equals to 3x, B equals to 4x, and the height h equals to 2x, right? So we have A, B and h with us. Now what is given to us? Area of the trapezium is given, right? So area of the trapezium is equal to 175 centimeter square. Okay, so formula is half into A plus B into h, right? So this turns out to be 175. Now let's put the values. So we have half into A plus B. A is 3x, B is 4x, and height is given to be 2x, right? So this is 175. Let's quickly simplify this. So 1/2 is there, so 3x plus 4x is 7x, into we have 2x is 175. So 2 and 2 gets cancelled, so we have 7x square. So keep x square here. So 175, bring 7 to the denominator. So do the cancellation. 7 2s are 14, 7 3s are 7 5s are 25, right? So we got x square equals to 25. So therefore from here x will be root over 25 is equals to 5. Okay, so we got the value for x. Now you need to find the height, right? So therefore your height becomes, see, height is 2x, right? And we are dealing with the unit centimeter. So we have 2 into x. X is 5, right? So let's multiply. So 2 5s are 10, right? So your answer turns out to be, that is the height turns out to be 10 centimeter, right? Okay, so you may pause the video and note down the solution. Let's move to the last question for the day. So question number 5, which says a parallelogram has sides of 20 centimeter and 30 centimeter. Okay, so there's a parallelogram. So let me see whether we have shape for parallelogram or not. No, I don't have any shape for parallelogram here. That's okay, fine. Okay, so there's a parallelogram. Okay, so let me quickly draw a rough diagram for you. So there's a parallelogram. Okay, so in this parallelogram, what happens is, so in this parallelogram you have two sides given. So one side is given to be 20 centimeter and another side is given to be 30 centimeter. Okay, and the distance between the shorter sides, see, this is 20 centimeter, then obviously this will also be 20 centimeter, right? Okay, and if this is my 30 centimeter, this will also be 30 centimeter. Okay, now it is given that if the distance between the shortest sides is 15 centimeter, okay, that means if you which one is shorter, by the way? Out of 20 and 30, shorter side is this one, right? So basically distance between shorter sides means shorter side, distance between the parallel sides, right? So distance between parallel sides is called height. So if the distance between them is given, that is this becomes the height, then your base becomes 20 centimeter. Okay, so given is, I'm sure you are able to understand this. So given is distance between shorter sides, that is 20 centimeter sides, is equal to, okay, so distance between 20 centimeter sides is given to be 15 centimeter, right? So therefore I can say that my base is 20 centimeter, and when base becomes 20 centimeter, that is the distance between them becomes my height. Okay, so height is 15 centimeter. Now let's find the area. Okay, so therefore area becomes base into height. Okay, so let's find the area. So base is 20 and height is 15. So this becomes centimeter square. So when you multiply these two, this becomes 300 centimeter square. Okay, now see here carefully. Now what will I do is, now I'll take, see, question says find the distance between the longer sides, right? So we have to find the distance between these two sides. Okay, now if I call this to be the base, then the distance between them becomes my height, isn't it? Okay, now when base is equals to 30 centimeter, what is the height? That's what you need to find, isn't it? Okay, so we know, right? So we know that area is how much? We know that area is, we know that the area is how much? 300 centimeter square. Now let's write area formula as base into height. Okay, so base into height is given to 300 centimeter square. So base is 30 centimeter, right? Or let me write just 30 into height. We don't know height, right? So we don't know height, and this is going to be 300. Okay, now bring this 30 to the denominator, so you get height is equals to 300 by 30, which becomes 10 centimeter, right? So that means when the base is 30, okay, then your height is 10 centimeter. That is, the distance between them becomes 10 centimeter. So that's why we say at last, therefore distance between longer sides is equals to how much? It is 10 centimeter. Okay, so you may pause the video and note down your solution. Okay, so your homework is on the screen. Okay, so you will do these homework and submit your work to me. And with this, we close for the day. Thank you very much.